Hello guys, this is Bhaskar here. In this video, I will be talking about how to use machine learning algorithms to detect breast cancer. So this video will be quite long. So the beginners please follow along, and the ones who are familiar with the machine learning algorithms can increase the video playback speed. I have added the source code to my GitHub repo. I have added the link to my repo in the description below. Okay then, let's get started. First of all, to start this machine learning end-to-end project, we will have to download the dataset. We will download the dataset from Kaggle. Okay, from this link. Yes, I will be putting this link in my description. You can go to this link and download it. I have already downloaded this dataset. You can, by pressing this button, you can download. Okay, now let's go back to Spider. I will be using Spider, and you can use any IDE of your choice. I personally prefer Spider because it's very easy to use and it shows very much information here. So it's my personal choice, doesn't matter, but it's upon you which IDE you use. Okay, now let's come back to our project. Okay, first of all, we will importing our libraries. Okay, import it. Yes. PTS. Import and matplotlib. Plotlib. Matplotlib. Okay. Dot pyplots plt. Okay then. Now we will be importing our dataset. Okay. Dataset equal to, we will be calling our panda library to read. And to check that if it's working or not, we will be running this code. First of all, we will be loading the directory, like setting the directory to its correct folder. We'll go here and check. Yes, yeah, I have put this my data set here. Okay, let's see then. Okay, now we'll be importing the data set. Okay, okay, yes, data set. Oh shit, set equal to, we'll be calling the pandas library here. CSV. Yes. Okay. Let's see. Yes, it's working. Okay. Now we will be setting our, sorry, we will be dividing our data set. Okay, first of all, let's see if it's working good. Yes, see, this is our data set. Yes, here we can see a huge data set consisting of how many entries? Yes, like thousands or maybe. Okay. Yes, about 568 entries. Yes, it comes 568 entries, and it consists of various characteristics. Yes. Okay. Okay, we will see about which one we want. We will divide it into X and Y data set. Yes. Yes, see our first part. Yes. In this dataset, you can look at the first column because beside second to the ID diagnosis M here, or you can see or B here. This M is for malignant and B is for benign. And the other features are the various characteristics on which this results depends on. Okay, then let's get started. Okay, let's start with X dataset dot I log, sorry here. Okay, and the y will be the actually this 2 from 2 to 32. Actually there are 32 columns. I log. Okay, what's the error here? Undefined name. Okay, yeah, yeah, now it's correct. Okay, yes. Okay, let's see if it works or not. Okay, okay, we have to rerun this code. Yes, yes, and now this will work again. Yes, see, see, this X part consists of all the independent variables. See, of the various radiuses, diameters, etc., etc., and this Y part, this is the result. That is whether the cell is malignant or benign. Now we want this Y set to be binary, because if this is in letters or in characters, it will create problem for our machine learning model to predict the data. So for converting these characters into binary format, we will use some of the libraries. Okay, now we will encode these characters into binary form. Let's comment it out. Okay, we will use a library from sklearn, where we will use the sklearn library, sorry. And we will use the label encoder. Okay, 1 minute. Yes. Okay. Now we will name this object. Now we'll call out. Yes. And now we will rename, we will it's not rename, we will replace our y dataset with the binary form. Let's see how. Y will be equal to, yes, we will copy this. Okay. Yes, y 10 dot, we will fit transform. Yes. Okay, let's see if it works or not. Okay, see here, the y changes. Yeah, see, y. Here the one thing stands for malignant, and 0, yes, 0 stands for benign. Okay, now we can proceed for setting our, okay, now we can proceed for creating our machine learning, sorry, no, okay, now we can proceed for splitting our dataset into the test set and the train set. Okay, we will use a library that is sklearn dot model selection. Yes, and from there we will use train test split. Yes, wait, yes, here it is. Okay, we will here write the various splits we will use. String x, okay, x test y train, okay, and y test. The split x, then we will use y, that is, these are the various, these are the hyperparameters, okay, from x and y. Yes, and okay, we will use test size equal to 0.1. This means the split between the train and the test set, that is about 10% data will be gone to the test set, and the remaining 90% data will be going to the train set. Then one last parameter, that is the random state. We will keep this as 0 as we don't want other things to be changed. Yes, yes, looks like we are done here. Let's see the splits. Yes, see, x train, x test. y test and y train. Okay, now before proceeding to our machine learning model, let's scale our data. Like, let's feature scale our data. We feature scale our data to get a good accuracy. So for feature scaling, we will be using another library from sklearn dot preprocessing. Yes, we will use standard scaler. Yes, standard scaler. This we will use for we will use as an object here. Okay. This will use as an object. Now we will first scale the train set x train. Okay. Yes. Now we will fit transform. So that it fits. Don't want this. Okay. Yes. Okay, let's see if it works or not. Okay. Yes, it's changed. See here, it is properly scaled. Now you can see a proper scaling is done throughout the data, both in the x test and the x train. Okay, now we can fit our data to the various machine learning models. So first we will go for the random forest model. Okay, to fit our data into the random forest model, there is also a library in sklearn. Okay. We will use ensemble. Yes, and here we will import random forest regressor. Okay. Yeah, see here we get a predefined random forest regressor. We will copy this. Yes, here we have to enter some of the hyperparameters that is listed here. This is the n estimators. This is the number of trees we want to use. And we will keep the random state as 0 again. it's time to fit our data to our model. X train, right. Now let's write the code for predicting the results. Let's comment it first, then now so predict X test. Okay, let's see are this part of code box or not. Okay, yes, see here, it's done. Our data is fitted perfectly into a model. Now let's see our results. Okay, vibrate 1 and see, you can check the accuracy by visuals. You can compare how your predicted outputs are, how good your outputs are. But you can see here that some of the outputs have, like, they're coming in 0.068, something like that. So for that we have solution here. Okay, for converting them into perfectly binary one, we will convert, we'll go now to numpy library. Okay, let's see now. Yeah, see, now it gets changed. Now they are perfectly zeros or they're perfectly ones. Now let's check our accuracy. For calculating the accuracy, we will again use libraries from sklearn. Yes. Tricks. We will import score and accuracy score. We gave a space, then the error is done. Okay, for the accuracy score, y test, here slight change, yeah. For the f1 score, okay, let's first import them, then let's check our accuracy first. Okay, our accuracy is 92%, approximately 93%. Let's check our f1 score. Yes, 0.91. So it's probably good. It's above 90. It's above 90% accuracy. It's good. Okay, and now let's check. Let's fit our data in another models. Let's go for KNN. Again, we will use library from sklearn. This time we will use dot neighbors. From there we will import kneighbor classifier. Here now classifier will call out. We'll copy this piece of code. Yes. We'll give some hyperparameters and neighbors. Yes. Let's take it to 8. Okay. Then metric will be equal to and p will be is equal to 2. Okay, looks like we're done. Let's fit it. Okay. Let's comment it. Dot predict method x test. Yeah. Okay, let's run it. Let's import. Now let's fit. Okay, looks like we are done. Now let's predict our data. Okay, where pipebread 2. Okay. Yeah, here it is. Okay, let's check our accuracy and F1 score. Okay, let's copy this piece of code from here as it's same. Okay, and let's change this. Copy it, paste it here. Okay, done. Let's import them. Okay, now let's check the accuracy. Yeah, looks like here we have a good accuracy, 94.7%. That's, we can say 95% accuracy. It's good. Let's say the F1 score we get here is 0.93. Okay. Now we will fit our data in the naive Bayes model. For this we will use sklearn dot naive Bayes. Yes, from here we will import Gaussian NB. Yes. I will call this as an object. Yes. Now we don't need to define. If you see here, okay. Now let's feed our data. And white ray. Be equal to class C dot predict method. Okay. Let's fit our data in the naive Bayes. It's done. Okay. Let's predict. Oh, what I've done. Let's predict. Okay. Yes, here it is. Let's check the accuracy score quickly. F1 score. Yes. Okay. Let's change these names. Okay, done. Okay, let's do. Okay, accuracy is a bit low here. It's similar to the very first one, the decision for the random forest model, not the decision, random forest model. And let's check the accuracy. The F1 score here we have 0.89. Okay, now let's go for another model. Let's try and fit. Okay, now let's go for the random forest classification. Here we will use sklearn.ensemble again, and then here we will import. Okay, import random forest classifier. That's an object. Copy this code. Slime. Okay. Now we will enter the various hyperparameters. And estimators will be, let's take it as 180. Actually you can check for different number of n estimators, like for which the results are better. So at first so after some attempts, so I found that for n estimators equal to 180 I get a good accuracy. Plus criterion will be equal to entropy. And last we will take the random state as 0. Okay. Now let's fit it. Predicting 2 dot predict. Yes. Okay. Let's fit our data. Yes. Fitting of data is done. Now let's predict. Okay, yes, here it is. A y present our y test data. Yes, here it is. Here, see. Okay, now let's check our accuracy. Let's take this code from here. Change this swipe 4 and this. Okay, let's import. Let's check the accuracy first. Okay, yes, we get the accuracy as 96%, so it's a good accuracy. So this shows that our data fits the model perfectly here. And for the iPhone score, yes, 0.95. Yes, we can say that this is the best model among the models that we have checked. And also you can find out the number of incorrect predictions by taking out the confusion matrix. For setting the confusion matrix, we will take a sklearn library. Import confusion matrix. Now see, equal to, let's copy this. Okay. First we'll enter our actual dataset, this is y test, and our then our predicted dataset. And for the last one we will check out. Okay, let's do it. Okay. Matrix, matrix actually. Sorry here. Yes. Now it looks good. Okay, done. Now let's do it. So where is CM here? Okay, yes. Okay, these are the correct predictions. This we get two incorrect predictions. Okay, I can see here. So this was all about the breast cancer detection through machine learning algorithms. There are much more machine learning models which you can try on your own. These are some of the models which I thought to try it on and test it on. So hope that you liked my video, and feel free to ask any questions or any doubts for them. Take care.